Hi everyone, today I would like to talk very briefly about the rest of my previous video, part 1 regarding the cold room for frozen food items. The ambient air is 35 degrees Celsius at relative humidity of 60%. Cold room indoor design temperature is negative 40 degrees Celsius, and the temperature difference between ambient air and the cold room is 75 degrees Celsius. The U value for the roof is 0.25 watts per square meter Kelvin, 0.35 watts per square meter Kelvin for the walls, and 0.30 watts per square meter Kelvin for the floor. To calculate the cooling load, we'll use this formula: Q equals U multiplied by A multiplied by T1 minus T2 multiplied by 24 hours divided by 1000. Let's start with transmission load. We have an area of 9 square meters for our roof. Q1 equals 0.25 multiplied by 9 multiplied by 35 degrees Celsius minus negative 40 degrees Celsius multiplied by 24 hours divided by 1000. That comes out 4.05 kilowatts hour per day. And the area for the walls is 48 square meters. When we drop in this, that comes out 30.2 kilowatts hour per day. And the area of our floor is 9 square meters, and if we drop in, it comes out 3.30 kilowatts hour per day. And the next internal load, 2 people, each of them has a loss of 275 watts multiplied by hours of working per day divided by 1000. That comes out 3.3 kilowatts hour per day. 2 lights multiplied by wattage multiplied by hours of use per day divided by 1000. That comes out 0.96 kilowatts hour per day. Equipment load, 10 fans, and if we drop these numbers in, that comes out 18 kilowatts hour per day. Infiltration load, 3 air changes per day, that comes out 7.5 kilowatts hour per day. New product load, 1000 kilograms of spinach, and if we drop these numbers in, that comes out 51 kilowatts hour per day. Respiration load, 1000 kilograms of spinach, though dropping this number in, 2.66 kilowatts hour per day, and adding these numbers in gives us a total cooling load of 120.96 kilowatts hour per day, multiplied by a safety factor of 1.1. that gives us a total cooling load of 133 kilowatts hour per day. And the last part is working area cooling load calculation. The ambient air is 35 degrees Celsius at relative humidity of 60%. The working area indoor design temperature is positive 13 degrees Celsius, and the temperature difference between ambient air and working area is 22 degrees Celsius with a U value of 0.25 watts per square meter Kelvin. For our roof, 0.35 watts per meter square Kelvin for our walls, and 0.30 watts per square meter Kelvin for the area of our floor. To calculate the cooling load, we'll use the same formula: Q equals U multiplied by A multiplied by T1 minus T2 multiplied by 24 hours divided by 1000. Next, transmission load, 5.4 kilowatts hour per day for an area of our roof, 32.2 kilowatts hour per day for the area of our walls, and 3.8 kilowatts hour per day for the area of our floor. And again, we have internal load, 2 people, each of them has a loss of 275 watts multiplied by hours of working per day and divided by 1000, that comes out 3.3 kilowatts hour per day. Full lights multiplied by wattage multiplied by hours of use per day divided by 1000, that comes out 1.92 kilowatts hour per day. Equipment load for the working area, we use different units such as split AC or window AC unit, which does not require to be accounted for equipment load. And lastly, infiltration load. When we drop this number in, we see that comes out 8.9 kilowatts hour per day, and adding these all numbers in, that comes out total cooling load of 55.52 kilowatts hour per day for our working area. So that's it for today. I appreciate you for watching this video.